Good morning, everybody. We're ready to start. Thank you for coming. My name is Peter Hilton. I'm going to talk about Play 2. So if you wanted to know about Clojure, you're in the wrong talk. That's next door. If you want to tweet about the talk, ask me questions, complain about the slides that are not funny, then use the hashtag. I do have to apologize. I'm not Guillaume Bohr. I'm not the creator of the Play framework. People at conferences tend to want the founder of the framework. That's not me. I'm not even French. The most important thing to introduce myself is to say that I'm a web developer. I have called myself a Java developer in the past. There have been other programming languages. There will be other programming languages. But the thing that I really like is building web applications. And the thing I really care about is building web applications the right way. And so that's a lot of what this talk is about. It's about what is the right way to build web applications, and what is the right architecture, and what does that mean for your choice of web framework. So Play is that web framework. That's the short version. And it's not just about having the right architecture. It's also about it being fun. And what makes it fun is that you can get a lot of stuff done quickly. And Play brings high productivity. I'm going to have to explain what that means, but my experience of switching to Play from using previous Java EE web framework technologies, and I'm mostly blaming JSF for everything, so I apologize, JSF people, is that with Play, you just get so much done so quickly that it becomes fun again. So, what is Play? And why does Play matter? That's where I'm going to start. And I'm going to show you a little bit about what Play looks like, what kind of code you write. But I'm also going to talk about the architecture, and I'm going to talk about why Play is different. Because it's a web framework, and there are a lot of Java web frameworks. So why could we possibly need another one? That is a good question, and I think a question that I'm going to try to answer. So just to start with what is Play, because a web framework could mean more than one thing. Play is a particular kind of web framework. Play is a full-stack web framework. Now, what that means is that Play has a lot of functionality out of the box to build a web application. It's not just a thin layer that is one component you use in a larger application architecture. The first Java web framework I used was Struts 1.0 way back when. And Struts was not a full-stack framework. Struts gave you the web tier, but it didn't give you a database tier. It didn't give you functionality for user login or a way to send email. There were other libraries for that, which was fine. And so we built applications. But we did have to pick some other components. More recently, there have been other web frameworks that introduced the idea of a full-stack framework. And so when I started using JBoss Seam, for example, that was actually quite a new idea for me, that I've got everything I need to build most applications. Grails is a bit like that as well. That there'll be more components bundled, more modules available, that you won't have to pick and choose yourself. And this matters because if you don't have a full-stack framework, you won't be sure if these things are going to work together. So, you can, I mentioned Clojure earlier. Well, Clojure's cool. Well, it must be because it's a Lisp. And you can build a web application with this, but there's not a full stack framework. So you're going to have to pick a web tier, a templating solution, and you're going to have to experiment to work out what works together. You're going to have to make your own architectural choices. And it's useful if you've got a web framework that gives you the starting point. It also means you'll have more consistency with other people who are using it as well. So that's nice for for working with the community. What kind of web framework is Play? Play is a web framework that's very much focused on HTTP. HTTP is the web. Maybe HTTP plus HTML is the web. And Play thinks that is the basis for building web applications. That the API is based on HTTP and the templating is based on writing HTML. Not components, not trying to hide the HTML. It's designed with newer architectures in mind. When Java EE web stuff first got started, we had different ideas about how we should build web application architectures and how we should scale them up. But going back to the earlier slide when I said I'm a web developer, Play is fundamentally a web developer's framework. And it's built by web developers, not just for web developers. What that means is that if you're a Java developer, you'll be thinking from a Java perspective, and you'll build a certain kind of web framework. But if you're not thinking about the web as primary, then you'll make something that is a Java style of thing, not a web style of thing. So let's talk about what that means, because that's kind of a subtle idea. So to talk about the web as an abstract thing is tricky, but most of what's important about the web is just obvious in the web browser, or most of what's important about how the web should work. So I'm going to talk about the web browser, and I'm going to talk about functionality in the web browser that your web application should have. So what is the most important feature in a web browser? The most important feature is the back button. It's what people use the most. I think that's because most web pages suck. And so you go to this website and you just want to get out of there and you want to go back. And at a certain point, we had technologies and web frameworks that would break the back button. And this is a terrible thing. This is really awful, that we would build web applications where the most important feature in the browser would be broken. And we would sort of try and rebuild it somehow in our applications. And so don't break the back button. Just don't do that. The reason it's a bad idea is what I say at the end of the slide here, is that some technologies think that the web should work differently and it should be stateful. And so you shouldn't be able to go back, because you have some states. You can't go back in time. And this is a different kind of architecture, but the web's architecture is stateless. And if you fight that, it turns out the web is more important than any other technology, any particular web framework. And so when some web framework says that this is wrong and goes up against this and starts this fight, it turns out that the web always wins. The next feature is that you can reload your page. So if you're publishing a static website, it's 1994, all web pages have a gray background, and you type some stuff in your HTML document, and you go and hit reload in the web browser, what happens? Well, what you want to happen is that you see the changes that you just saved in this HTML document. I mean, that's a pretty basic thing. The idea that you modify something, you reload the page, you see the changes. And so as web developers building web applications, so not HTML documents, it's kind of nice if the same thing happens. And so if you've ever been a PHP programmer, this is how it works. You've got a PHP file, it's got some code in it. I mean, it's probably horrible, messy code, but you've got some PHP code, and you change that code, you go to the web browser, and you hit reload, and you see the code changes. And that's the way it should work. The reload button is supposed to show you your changes. It makes you fast. It means that you don't have to wait around for some build to complete. And that's important. The next thing that I can show you in just this same picture is that URLs are a big deal. They're a big part of the design of the web that is very clever. It turns out that having addressable HTTP resources, as you might call them, is a very powerful idea. The idea that from the very first web application, which was a telephone list, a telephone directory for inside an organization, the idea that every entry in some application should have a URL and that you could go to that URL is part of what makes the web scale and work. And this is how websites work. A website is a collection of web pages, and each page has a URL. And you type in that URL, or you click it in an email, or you tweet it or something. And you get the same web page. And yet, many of us have been involved in building web applications where that's not true, where you copy-paste the URL, you email it to somebody, and they click it, and instead of seeing the same web page, they see your session is expired. That's not cool. What you want is, a product catalog that lets you say, show me the comments for product whose identifier is 42. That's how the web is supposed to work. And finally, in recent years, I think the idea of usability has actually gained ground in user interface design. It's not a niche thing. Once upon a time, you're that annoying person who is saying, wait a minute, what about usability? What if this user interface is horrible? I think it's now time for the same revolution in the developer experience. So we're programmers writing web applications. What about the usability in our tools? What about the web framework actually making it easier for us to build web applications? I mean, it's all very well if you are some kind of genius. If you're Linus Torvalds, you don't need usability because you can just use anything, however horrible it is to use. It's probably not a coincidence that his source code control Git means something in English, and it's not a nice thing. I think he's been quite explicit there about designing something that just doesn't care about usability. But as developers, we're people too. We want tools that are usable. And so get a web framework that thinks about the developer experience, not just the user experience. And specifically, it's going to be things like error messages. When I was going through the rest of the screenshot here, I was left with the heart, the little icon. And this is the default favorites icon in a new Play application, in certain versions of Play. I had no idea what that meant. So I asked Guillaume Bohr, I said, Guillaume, why is there a heart icon? And this was his reply. He said, there's no story. I said, what's the story behind the heart? So, that's why I sort of used it on the previous slide as sort of, it's the love for the developer. But I just made that up. I mean, I don't think that's actually true. I don't know where it came from. Nobody knows. Okay, so I'm going to make up the story. Guillaume was thinking about the love for the web developer and chose the heart icon. There, it's true. So, this is why Play matters, because it doesn't fight you. It doesn't fight the web, and it doesn't fight HTTP. In other words, it's HTTP-centric. And this is what makes it an important framework, because it cares more about the web than it does about Java traditions, about Java EE conventions, about complex architectures. Because the web, HTTP, these are simple technologies. But I don't think anybody has ever accused Java EE of being about simple technologies. Sometimes there are technologies who have an acronym where the first letter is S, like soap. And sometimes people have this idea that S stands for simple, and they're kidding. It's a lie, it's a joke. It's the biggest joke about SOAP is that they say, let's call it simple object access protocol. That's not what it means. So I've talked a lot about how the web works, but I haven't actually explained any of that. And I don't have to explain that, because like all good software, the web has technical documentation. So if you haven't actually ever read the architectural documentation for the web, you really should, because this is a very useful description of how it is supposed to work. And when you read this, think about one thing. Does my web framework let me do this? I hope that you can read this and think, oh yeah, I can do that. I can do that. I can make my applications work that way. But if you're using certain frameworks, if you're using certain web frameworks that have a different idea, that think that Java EE style conventions are more important, you will read this and think, well, that's all very well, but I can't really do that in my current technology. And that is a bad sign. That is a sign that you have technology that has a mismatch with the web. And so a specific example of that, which I mentioned that is very important, is that the web is stateless. HTTP is based on a stateless request and response. You send an HTTP request, you get an HTTP response, and then that's it. There's no sort of memory in HTTP. If there's some kind of state, if something's been remembered, it's somewhere else, but it's not in HTTP. It might be in the form in your web page. It might be in a database somewhere, but it's not in HTTP itself. And so if you build web applications that are themselves stateless, this just turns out to be much easier because you haven't created some kind of mismatch between your application and the way the web works. If you do make a stateless web tier, you're probably still going to have state in back-end persistent storage, like a database. And if you have any user interaction, you have state in the client. Because as soon as the user of your web application selects a checkbox or types something into a text field, that is state, that is client state that they've introduced. And now you need to synchronize that with your backend. And if you're a programmer, there are certain words that should make all of the alarm bells ring and make you double all of your estimates. And synchronize is one of those words. If anybody tells you to implement, just make these two things synchronized, you should be very scared about how long this is going to take you to make it work. This is why things like Dropbox are actually quite special. And this is why projects like Chandler took a really long time trying to work out how to synchronize calendars, because it's hard. And so don't introduce additional unnecessary layers that you have to synchronize. You'll just end up with lots of work and more complex architectures. And deploying to the cloud turns out to be really easy if you're stateless, because you can scale horizontally across lots of servers. And there's no state to synchronize between servers either. So it doesn't matter which server your next request goes to. That's nice. So I mentioned statelessness, web architecture. But earlier on, I also mentioned high productivity web development. And I think all of you know this, but I'm just going to have to repeat it, that when you're a Java developer building web applications and you're sitting there waiting for your changes, your one character code change in your Java class to deploy, and for your build script to run, and your application server to restart. Meanwhile, 100,000 PHP developers are laughing at you because you're ridiculous, and they just hit refresh. They just go to the browser and hit F5 and they're done. And then they watch you loading your application. And they're right. It is ridiculous. There are good reasons why we ended up with that kind of technology, but we somehow forgot that it's not necessarily the way things have to be. And so if, when you hit refresh in your web browser, code reloading actually works, it turns out that you can build stuff faster and that it is therefore more fun. And that's really, really cool. It's a completely different experience. And so that all by itself is where a lot of the warm feeling comes from using this kind of technology. It's why some of us, secretly have our own personal websites actually implemented in PHP, even though we're Java developers at work. Because it's just easier. You just tack something out and it's just there. And you can be done quickly. It's important to point out that in many environments, reloading is possible, but sort of in theory. There are technologies for JVM class reloading, and they work. But you do have to get hold of that technology. You do have to work out how to use it. And for some reason that I'm not quite sure about, most of us, myself included, we don't do that. We don't have that kind of hot reloading JVM stuff set up. We know we could if we had time, but we don't because we're busy. But maybe we know somebody who's doing it, so it's sort of hypothetical. We don't really have it all working. And the other thing that's important about code reloading is that there's more than one kind of code. It's not just your Java class, and it's not just your template. It's also various kinds of configuration files. And so if you can just change anything, and then go back to the browser and submit the form again, without having to do anything else, this makes you highly productive. If you've noticed, I'm just saying all the same things again that I said in the slides with the web browser screenshot, because it's important. So the next thing that I'm repeating is the story about URLs. The URLs matter. They are part of your application. They are part of your application's public interface. And if you're thinking in terms of REST architecture, it is literally your application's API. And so you should design that too. You shouldn't feel comfortable if your technology says, it's fine, I will just give you a URL scheme, and you can't change it, and don't worry about it, and it doesn't matter. And people don't really look at URLs, or type them in, or try and edit them, or delete parts to go to another page. or try to remember them. But they do. And so this is part of the application you should design. And it turns out that it can be really useful to design a good URL scheme for your application. And bad things happen if your technology gives you this. This is not cool, but we've suffered this kind of thing for years. You know, and it's just horrible. Ugh. So what you want instead is you want the ability to say, these are the URLs that I want to have, and I would design them. So let's, you know, and this I'm starting now to show you how this works in Play. In a Play application, you design the URLs, perhaps in your head, or on a piece of paper, on the back of a napkin, and then you just sort of type them in a configuration file called the routing configuration file. And so lines in this file, if they are not comments, simply have an HTTP method, like get, a URL path, which may include parameters, and then the name of a controller method, the code that will be executed, the entry point into the application for this URL. This is very convenient to do. And so here we can already see that Play is an action-based web framework, like struts was in the beginning, where you receive an HTTP request and you map that to some Java method and execute that method. This is really easy to do. And this means that you can design a URL scheme and have a whole file. And so this is, you know, imagine a product catalog where we've got a list of products and we've got a product details page and we've got a JSON feed because there's some AJAX going on. This is a thing of beauty. You know, you should be able to do something like this. In fact, you could even start designing your application here. Some people start building their applications by making the data model and then seeing what user interface sort of drops out. Some people start with the user interface design and then they kind of make it work. But you could start here as well. You could say, you know, what are the resources that my application is going to have? And this is a really nice way to work. The last time I showed this to somebody earlier this week, Java developer, he asked me, well, okay, but can I put all of this information in annotations in my Java code instead? And that's a really Java kind of question. It's not a web developer question. Because from a web developer perspective, the web interface is more important than how it's actually implemented. So it's kind of nice to have it in one place. Whereas from a Java developer, you're thinking that your classes are more important. And so can we just like have everything in the Java class? And that seems like a good idea. This is how a lot of quite good web frameworks work. I think Spring MVC, for example, deservedly popular, does it that way. But it's slightly too much of a Java focus. And this turns out to be really nice. Ironically, this is the way the first Java web applications were supposed to work as well. In the beginning, all we had was Java servlets. And the idea that was that you would write Java classes that would be servlets. And maybe, you know, if you waited a couple of years, JSP would get invented and you would dispatch these requests to JSP pages instead of using print statements. And you would configure this stuff in a file called web.xml. And you would map URLs to servlets. Unfortunately, the web.xml was far too crippled, too limited in what you could do. And so it wasn't really useful, so we sort of gave up on that at some point. And so now you don't really configure anything in web.xml, you just forward it to another framework that has another attempt at implementing something like this routing. But this is a really nice way to do it. Let's change subject again. I mentioned developer experience. So what does that mean? What is good developer experience and what is bad developer experience? Well, bad developer experience is when you can get stuff done, but it does help to be a genius because you need to think carefully to solve perhaps even simple problems. And so, in some web development environments that we've all used, you make a mistake, you make some coding error, and you go to the web browser once your application is eventually redeployed, and you hit reload, and you get a blank page because something went wrong. And you know something went wrong. You know that there was some kind of error because you were expecting, you're expecting more than a blank page. But that's okay, because we're Java developers. So we know that the error is really in the stack trace. So you go and look at the stack trace to find the error. And so then you see this. Because, you might have this like big fancy monitor on your desk, but it's still not big enough to see the whole stack trace. And you know that the error, this is just other stuff. All of this is here because your web framework is made of so many layers that there's this really deep call stack. And so that the error is further down. And so, you scroll down, you scroll down, you scroll down, searching for the error. And you still can't see the error because it's down here on the floor somewhere. It's underneath. It's underneath all of this. Somewhere down here, there is a caused by that will tell you what actually went wrong. And we're so used to this that we don't really question it. I'd never questioned it. I thought this was just the way things were until I saw something like this, a web page with an error message in it and the code that contains the error. And so I went to the web browser to see my changes, and instead, not only did I see that there was a problem, I saw what the problem was, and I saw where the problem was. And so I'm already 90% of the way to solving the problem. Especially if it's something that's sort of fairly fundamental, such as, okay, I'm trying to do stuff with my persistent storage, like load a list of products, and yet I haven't got a database configured. There's no data source. That's quite a good error message. And so this is a screenshot from a Play application, obviously. I'm talking about Play. And this is really nice. The interesting thing about all of this stuff I've shown you so far, and all this story about developer experience and better error messages, was true in Play 1.0 2.5 years ago. And so for the last couple of years, I didn't use it immediately, but certainly for the last 2 years, I've been using Play and just thinking, wow, web development is fun again. And now, this year, there's Play 2.0, which is, it's not a sort of incremental update. It's kind of largely a rewrite, and has new stuff as well. So all of the stuff you've seen is in Play 1 and in Play 2. And then Play 2 adds even more stuff that's new. And some of it is quite significant. It's not just another feature that you could just add to another web framework. Some of this stuff is a different way of building a web framework, a different way of building web applications. So now I'm going to talk about some of how Play 2 works. So the first thing that's new is that apparently, Java is not the only JVM language anymore. And we've sort of known this for some years, because for some years there have been other languages on the JVM. But now what's changed is that the people using these other languages are getting a bit more serious and saying, sorry, we don't just want to play with these languages, now we actually want to build real applications. And for most of my career, real applications have meant web applications. And so the Scala developers, they need a web framework too. And if you're a Scala developer, it's all very well that you can find your technologies and put them together and work out how to build a web application. But it is a bit easier if you just have a full stack web framework. And so Play 2 supports Java for that reason, and Scala for that reason, that you choose. And so the way this works is that the public API you use when you build your web application is implemented twice. There's a Java API and a Scala API. And so this is an example of an action method. On one of the earlier slides, we had the URL configuration where you would receive HTTP requests and you would map it to some action method that would do something like, say, hello world. And so this is what that looks like in Java and in Scala. And they're pretty similar. And what's interesting to note here is that Scala's syntax is a little bit weird if you're not used to it. It's not as weird as it looks, actually. It's worth reading a quick tutorial just to demystify the syntax if you ever have to read other people's Scala code. But they do more or less the same thing in more or less the same way. And that's nice. It's nice to have this choice. There are other JVM languages as well. And so, I look forward to a bright future where, as a web developer, I just have more choices. Because maybe Java's just kind of not cool anymore. And Scala, it's kind of nice because you can do everything, but that's also bad because, I used to write web applications in Perl. And Perl is dangerous. You can write really nice code, except that nobody else can read your code. And you can do that in Scala too, which is it's sort of fun, but it's not necessarily cool if you're a big team developing a big piece of software over the course of some years, which is very explicitly what languages like Ceylon are for. So, I'm hoping that in future, I can show more examples here. I want the Kotlin version and the Ceylon version, and that'd be great. I'm still building web applications, it's the same for me. Play is actually implemented in Scala now, which is not something you really need to care about as a Java developer, but it does explain some of the ways that Play 2 can be better than Play 1. Play 1 provides a really nice API for writing web applications in Java. But in order to do some things that Java is not supposed to be able to do, it uses lots of bytecode enhancement. There's lots of magic. And so using Play 1 often feels like an act of faith sometimes. You're looking at code and you're thinking, this can't possibly work. But you go and refresh in the web browser and it does work. So apparently it's OK. And the API in Play 2 is a bit more explicit, a bit more straightforward what's going on, which is a nice thing. A lot of Play 1 users who are Java developers at this point say, well, I'm kind of worried because I'm not a Scala developer, and now I won't be able to read the Play source code anymore. And this is sort of true, but at least there are two qualifications to saying, yes, that's true. First, Scala's not that hard to read, but you just need somebody to explain a couple of things about the Scala syntax, and it becomes a lot clearer. And secondly, it's not like the Play 1 source code in Java is that easy to read either. It's got some pretty hairy stuff going on there, the bytecode enhancement. And at a certain point, you're several thousand lines of code into some class, and it's getting really hairy. You can tell it's getting hairy because the comments are in French, if there are comments at all. So, readability of source code is not only about how familiar you are with the language. It's much easier to learn to read something than it is to be able to write it yourself. So your mileage may vary. One of the things that I want to focus on in this talk is what Play templates are like. I think that's my favorite part of Play. I mean, other Play developers give different presentations and focus on different things. But I like the templates. And the reason I like the templates is because they're not fundamentally original. They take some really good ideas from the last 10 years and discard what turn out to be some of the bad ideas. And so one of the bad ideas is XML. There was a time when it seemed like a really, really good idea to make templating systems whose syntax was based on XML. And this was a reasonable idea. It was reasonable because we thought if everything's XML, we will have all of this great tool support. We have tools for working with XML. And it would be nice, and XML has namespaces, so we can have HTML in one namespace, and you can interleave this with an XML-based template syntax. And although this seemed like a really good idea, it turned out to be a really bad idea. Because actually combining, well, I'll show you how this works, but if you've got a syntax that looks the same as what you're generating, they interfere with each other. I'll come back to that when I've got a slide I can point at. So before I show you actual templates themselves, I want to show you how you use templates, because this is one of the things that's a bit different. A template is just compiled into a method in a class, basically. That's sort of more or less true. And it uses Scala, but you can still do it from Java code. So the first line here is some sort of Java code at some arbitrary place in your application, where if you have a template in a class called products, well, you have a list template, basically, in a file called list. And you can render it, because it's just a function that you call. And you can pass it parameters. And so this is what you do in your code. And this function, the template, returns some HTML. So in an action method in your code, if you were mapping the URL /list to this action method, then the first line, you would do something like fetch the products from the database. That's what the first line does. And then you would render the list template, passing the products as a parameter, and then wrap that in an OK status response. So that's sort of what the Play API looks like. And this is much less mysterious than how other templating systems work. A lot of other templating systems are actually less integrated with your Java code, because what you have to do is you have to copy your data into some kind of map structure with string names. So, it's products, but as a name in a string. And then sort of kick off some separate template system that's disconnected. This is more direct. And more direct means easier to use, easier to learn, easier to debug. Nicer developer experience. The next thing that's really cool about these templates, this is now actually a template, is that they're type safe. And again, this was something that I'd never thought of myself. And then I saw it and I thought, well, actually that's sort of obviously a good idea. So in this template, the very first line is a parameter declaration. Just in the same way that if you have a method in a class, you declare the parameters and you declare their types so that you know what you can use. So for this to work, this template syntax is sort of obvious what it does. For this to work, you have to declare products. And you have to say products is a list of products. And this is what we're used to doing in our Java code, so it's kind of nice to do that in our templates as well. Why should templates be so different? Why should templates suddenly be this free-for-all, where we have this nice structured Java code? We may even write comments in that code. And then we have templates, which become this kind of mess with no comments and no declarations, and anything goes. If you're writing a big application and you want maintainability, then things like declarations actually help you. This is not a new idea. This is major innovation of the 1960s, probably. The thing I mentioned earlier about XML being a bad idea is about how it mixes. So I've done some kind of fake syntax highlighting here, where everything that's black is the template syntax, and the blue parts are just literal HTML. And so the nice thing about this template syntax is that you introduce it with this special character, the @ sign. And then for the rest of the statement or expression, it's template syntax. And there are no angle brackets or no quotes. And if you try and do this in XML, you make for an XML tag, and that's great. But then your front-end developer comes along and says, I want a CSS class on the list. And so in the UL start tag, you say class equals, and you put some quotes. And then inside that attribute value, you want some sort of generated class, or you want to do it inside the list item. You want to say odd, even, odd, even, odd, even. But you can't put XML tags inside attributes and still have a valid XML document. That doesn't work. So then you have to have an expression language as well as the XML. And suddenly it's twice as complicated. Now you don't just have XML, you have XML and an expression language, because XML wasn't enough to solve the problem. And things get more complicated. And you don't need that here. There's just one kind of template syntax. The template syntax is a little bit strange. It's a bit strange that at the end of an expression, there's no closing delimiter. As I said, you have this parameter declaration. The template syntax starts with this @ symbol. If you're a Scala developer, you will have probably worked out by this point that template syntax is just Scala. It's just Scala code. But if you're not a Scala programmer, that doesn't really matter, because it would just be nice and simple anyway. And maybe you'll do less complex things in your templates. In Play 1, the templates were based on Groovy. And that was not really a big deal, because you didn't really need to learn Groovy to use the templates. You just had this fairly straightforward template syntax. And what's nice about this is that it doesn't really interfere with the HTML. And so one of the things I mentioned earlier is care about the web. Don't fight the web. And in this case, this means hand code your own HTML, or have your front-end designer give you handcrafted static HTML that's the mock-up for your web application. And that's not a problem. You don't have to say to your designer, I'm sorry, we're using components. You can't choose the HTML. They just come from the components. So your design is all very nice and pretty, but now we're going to have to throw it away, because this is what forms look like. And that works for some kinds of applications, but not if you want to build Facebook, or not if you want to build something with a kind of innovative visual design. You have to work with the designer. You have to work with HTML technologies, and so this is very easy here. Another small example in the syntax, you might just output an expression. And so the size of the items list, I should say products, that's a typo, by the way. It won't compile. The size of the items list is just an expression, so that would be some number. And because that expression doesn't contain any HTML special characters, you can put that expression anywhere, such as inside an attribute value. It's also quite concise. That's the other problem with XML. XML seems like a really good idea, and it is in a lot of places where it makes things readable and well-structured, but it does make your templates 1,000 lines long and ugly. And if you are a front-end developer, if you're designing a user interface, I really hope that you care when something's ugly. I really hope that you want to make something beautiful, because if you don't, you're going to be responsible for one of those horrible web interfaces that we all hate. You can do other cool things in the template syntax. You can define tags, except that tags aren't really a special feature. I mean, some template systems have this special feature called here's how to define tags. And all you're really doing here at the top is defining a function called display that takes a single product as a parameter. And in the block inside the curly brackets, you implement 3 lines of HTML, which is a hyperlink. And then, later on in the template, and these could even be in the same file, you've got a lot of freedom about where you define this display. You can just use the tag, pass the product as a value. And what happens here is that your own tags or your own invented template syntax actually look as if it's built in. It looks like part of the syntax. There's nothing fundamentally different between the for loop and the display. So you have a lot of nice ways to reduce duplication. Another simple example of something you need to do typically in templates is maybe include other templates. And so again, in some systems, this is a special feature. But here it isn't, because if you remember from a few slides ago, a template is just a function. And to render the template, you just call the function. And so imagine that you've got another template that defines a page footer in a template, and the template is just called footer. It's in a file called footer. Then if you want to render that template, you just call the function. That's it. No special syntax. And so because the syntax is nice and powerful, it doesn't need to have special cases. This is really cool. Here's a sort of a similar but slightly more complex example. Here I'm showing you 2 different files. And so the templates live in a file whose extension is .scala.html. This is so you know that it's a Scala template, but it renders HTML. And so the top template is a function that takes 2 parameters, one called title and one called content. And so you can sort of work out what that does. It's the standard layout for your page. There's a funky Scala feature that's being used here, which is that in Scala you can have more than one list of parameters. So we don't have just 2 parameters. We have 2 parameter lists, which have round brackets. Now the reason we do that is because then we can use this other Scala feature that in a particular page that we want to be based on this layout, we call the main function, we call the main template, which is the other one, and we pass 2 parameters. But the first parameter is just a string in normal parameter syntax. I mean, that's what it would look like in Java too. But Scala lets you use curly brackets for the last parameter, which is the whole rest of the template. And this is actually quite a natural syntax for doing page composition. And so page composition, doing layouts, again, is the sort of thing that is often a special feature or special syntax in template systems. And here it's just a built-in feature of the fact that this is Scala. And so the basic cases here, you don't have to learn Scala to do these. You just copy-paste these and it works, and you can build pretty much what you need to build. You have your for loops, you have if statements, you have expressions, you can define reusable parts. If, however, you've actually made it through all 850 pages of programming in Scala, you might have some realization that you could use some sort of more clever tricks. So I was joking, you're not really ever going to finish that book. But if you know how to do some cool stuff in Scala, at a certain point you might realize, now I can do something in my template that is going to be much, much simpler, and you can use some feature that's not shown here. So it scales to to cleverer templates, and you have choices about how you use this. Okay, I'm going to switch subject again. I mentioned that templates are type safe. I mentioned that we like in our templates to have the same kind of thing we have in our Java code, which is parameter declarations. Another thing that we like are compilation errors. We like compilation errors because then you can fix them and then it works, as opposed to not getting a compilation error and discovering only later that it actually doesn't work. So compilation errors are good. Try to remember that. So for example, at the top I've got an action method for some details page. And it takes one parameter, which is an ID. And let's suppose we haven't actually implemented anything yet. This just returns an HTTP OK response. And the ID is a number, it's long. But if in the routing configuration, we define a route, a URL, that is mapped with a parameter to that action, we've got to get the type correct. And that's a mistake. They're not the same type. And so what happens if you do this is that you get a compilation error in the routes file. You don't just get compilation errors in Java classes. The root configuration file is compiled, and obviously you get a nice error message showing you the offending line of code. Type mismatch. It should have been long. We should have said long. This is great. Here's another one. In a template, this is, again, the same example from earlier. I'm going to output a list of products, and I've declared my list of products on the first line of the template. And yet somehow, I was distracted when I was writing this code, and instead of products, I typed kittens. And I get this, error, not found. Kittens not found. Who lost the cats? And so remember I said that compilation errors are good. It's a shame that they use this red color. That sounds bad. But compilation error is a good thing because you can fix the error. And so, because I want you to have warm, happy thoughts about play and not just think about play has loads of errors. Remember, these are positive. You will fix the errors and you will find the kittens. And so, if you only remember one thing from today's talk, remember this. Play framework, cute kittens. Meanwhile, we've just got lots of more compilation errors. This time it's JavaScript. Play does this by using the Google Closure compiler at application compile time. And so now I need to say something important about these compilation errors. These don't happen if you happen to visit the correct web page. They happen when the whole application is compiled. The application doesn't even need to be running. You can compile on the command line. So you don't have to write unit tests that go and visit every page just to check that there are no runtime, no compilation errors. Because JavaScript, will generate errors, but only if you execute it. And that's why Google Closure compiler is useful, because you can do this earlier. JavaScript has this kind of unfortunate property of being horrible. But that's okay, because somebody invented CoffeeScript, which is much less horrible. CoffeeScript is actually quite nice. So if you write lots of JavaScript, I do recommend that you look at CoffeeScript. And so Play integrates that, and the integration means that it also runs the CoffeeScript compiler and notices when you failed to implement the rescuing of the kittens, and you get a compilation error, and that is a good thing, because then you will actually rescue the kittens. CSS isn't horrible, but it is limited. CSS was designed not for programmers, but for designers. This was a very conscious choice. And so an example of something left out of CSS was variables. But as programmers, we think that's stupid because we want to define things like colors. It hurts a programmer Like, it hurts me every time I have to repeat myself in a CSS file and repeat the color. I just want to define the color once and refer to it. And this is what less does. So less is a extension to CSS that compiles to CSS files, but it's got a richer syntax. And it lets you define variables, which coincidentally have an @ symbol. If you're going to define variables, they do need to actually be, well, if you're going to use them, they have to be defined. And so you want to actually check that this is not an error. And so Play runs the less compiler and compiles your less file and discovers that while you optimistically wanted the background color to be rainbow, you didn't define rainbow. And so you get a compilation error. You get checking all over the place. And this checking is good for the developer experience, and it's good for high productivity, because it means that you discover and therefore fix errors more quickly. And that's very cool. Oh, and for those of you who don't know, you can actually define background color rainbow. I'm not making this up, because now we have CSS3, and we have web browsers that support things like gradients. And if you do multiple stops in your gradient, you can have a background color that's rainbow. And that works. So there's an actual screenshot. Well, not the animation, but the rainbow part, this is a screenshot of what you get if you do this CSS. Except that this is obviously messy and horrible. And so this is the kind of thing you don't want to repeat all over the place when you're designing your happy website that has rainbows everywhere. I mean, rainbows are kind of cool. But you don't want this in your CSS 20 times. That would be not cool. And so what I'm building up to here is that there are lots of really cool technologies for building web applications that the PHP crowd and the Ruby on Rails crowd, they will know about. But if you've been using the wrong kind of web framework in Java, you don't know about them. You haven't been able to use them. And so, make sure you choose a framework that lets you use all the new cool technologies. And Play is a good choice. That's what I recommend. And use less, and use CoffeeScript. And use all these cool new toys. And this is about not being constrained in how you build your user interface. Because otherwise you'll be limited to building Git applications that all look the same. Which is nice for your back-end admin stuff, but not on the public internet, please. There's another thing, a big topic in Play that I haven't talked about. So go and watch a presentation online by Guillaume or Sadek talking about reactive asynchronous web programming. Because in the long term, it's a really big deal. But I don't have time today. I also don't have time to tell you all about all sorts of other cool Play features. Because there's more. I mean, I've really focused on the templates and the HTTP part. But Play's full stack, so there's lots of other stuff there. And so just as an example, I mentioned that you can compile your application on the command line. It's got a console. And so for me as a web developer, I'm not really used to having a console, but it's nice to have. So you start the Play console. And one of the cool things you can do is you can start the Scala console. If you're a Scala programmer, you know that Scala has this REPL. A REPL is a read eval print line, which lets you type lines of code and just have them evaluated. And in the Play console, in this Scala console, your Play application is in scope. So you can render a template on the command line. Apart from just being a cool experiment, that's really important for testing. You can test your templates, your rendered templates, without using HTTP. So if you like writing unit tests, now they can actually be fast. So to wrap up, use Play. And now you've heard the talk, buy the book. A whole bunch of us are writing 2 books about Play. You don't have to use Scala. You can use Java. But buy both books anyway. And definitely buy my book. Thank you very much. I probably used almost all of the time, but I think we have time for some questions. If you have a question, wait for the microphone, but stick your hand up. No questions. Maybe microphone guy can. Oh, there's a question.
Those application here. Okay. those application compilation errors, is it just for a development switch? For normally, I don't want to show the end user my application bubbles.
Yes, yes. So the question is, do you always have to have these error messages? No. Play has two modes. It has a development mode where all of this hot reloading works and you see the nice error messages. And in production, you switch on production mode where everything's pre-compiled. There are no error messages. You see, your custom error pages, which will just say, please contact your sysadmin. Here's his phone number. And it will be also optimized performance-wise for production.
Okay, thank you. I'm here behind the camera.
Okay. Oh yeah, sorry, I'm looking the wrong way. Yeah, another question there.
Well, I have a couple of questions here. First of all, about IDEs, integrated development environments. Yeah. So, which ones are the best to use with Play? And for example, maybe even there, I can use Play like I use PHP. I just fire a Tomcat instance and then just edit my templates, and they just work. Can I use that? Another one is, you mentioned CoffeeScript. It would be really interesting to use like just Scala, which would compile to JavaScript. So then I could use Scala to write everything. My controllers, my templates, and JavaScript. Would that be possible? And the third question is, didn't you have any trademark issues with the biggest company in the world? Referring to Google Play, because yeah, so that's.
Okay, I think the answers are yes, 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 and no. So I'll try and remember what all of the questions were. There were no trademark issues because Play was first. This Play, Play 1.0 was released in 2009, and I think Google Play is more recent. Can you do more stuff with Scala? Play has a plugin architecture so that you can write Play modules. So if you can find something that compiles Scala to JavaScript, it would be possible to integrate that. The console you saw is actually a front end to SBT. So if you're a Scala developer, you can pretty much do everything using standard Scala tools. And so since that's such an obviously good idea, somebody is probably already working on a module that does exactly that. What was the first question?
About just, well, IDEs. And
oh yeah, IDEs. So Eclipse, NetBeans, and IntelliJ IDEA all seem to be popular. So the first part of compiler support, IDE support you get, is that the console has commands that will generate the IDE project. This is really handy because from this console, you create a new application, you generate the IDE files, and then you just open it in the IDE straight away. And it knows about all of the files, all of the dependencies are configured, and it knows where the sources are. The next level of integration, and that works in these IDEs, the next level of integration is things like syntax highlighting and auto-completion. There is some bundled support for that with Play, and there is an open ticket with lots of votes on the JetBrains IntelliJ IDE bug tracker. So if you use IDEA and you use Play, go and find that ticket and vote for it. I think and that's quite a popular one. I think they're going to implement that quite soon. But actually, your next question is very perceptive. Can I just use a text editor? I hear there are still people using VI and Emacs. And that kind of works because the compilation is handled by Play itself. You don't have to run the compilation yourself. So you can just edit your Java, Scala, or template files in Notepad or VI or whatever, and then just go and hit refresh in the web browser. And that works. And so if I had another hour, I would do some live coding, and I always start by just opening my application code in a normal text editor, just to kind of prove this point. But then I go and use an IDE anyway, because it's just more convenient. So yes. And that's one of the cool things about Play. Well, actually, that's 4 of the cool things.
Okay, so I have a question. Is Play following, let's say, convention over configuration principle? Because when you show the routing file, it was for me quite verbose. We have all those HTTP methods, different URL paths, and fully qualified name of the controller and the methods. What I would like to have is to just configure products are handled by products controller, and the framework knows that if get products comes, it is served by list method of this controller. When create comes, post comes, it is served by create, and only in special cases I redefine this default behavior.
The answer is, okay, so the question is, can I avoid having to write this routes configuration file? And the answer is sort of yes. It's yes because that's the way Play does stuff. In the other configuration file, which I didn't show you, everything's optional and everything has a default. In Play 1, you can do exactly what you just described, where you define one route, where it's slash class name slash method name, and this is mapped to class name method name. This hasn't been done for Play 2 yet, but people want it, so it's probably going to happen. And this is quite a common approach, is that you just, or you generate the routes file maybe, because you want this master details passion. I've got products with ID and list and edit and delete and all that stuff. And then I've got customers, and then I've got this whole data model, and I just want the same scheme. So yeah, that's quite a normal thing to do. Another question further back.
Is there any way to deploy a war application on my web server? On Play 2.0 and a server which implements 5.0 specification?
Yes, there is, but don't do that. Or at least, okay, so the question is, can I deploy my Play?
It's my company requirement.
Yeah, okay, I understand. So this is actually a very common requirement and a common question.
Yes,
and
how to smoothly go to Play framework, I think it's the only way for most developers just to first have
okay, that's the second question. So the first question is, can I do it? Yes, you can. There's a war deployment module. The reason that why I would prefer you to not do that is that if you use Play's own embedded HTTP server, you have some benefits. In particular, you're going to have the opportunity for better performance, and you've got some features in Play and things like WebSockets and suspending requests that you can do that aren't going to work in a servlet environment. But I understand that you want to do that as part of your migration to Play. The second question, which you sort of asked, is, is there another way to do this? Is there another way to migrate to Play? And there is. The other way is that you take a more Heroku-style architecture, or go and read 12factor.net and realize that instead of moving my whole application into this war environment, I will create a little isolated Play application that will have its own JVM somewhere and use web services. And so start implementing some small new things as remote web services. The control over HTTP makes Play a very nice way to implement RESTful web services. And so what you could do as a way to migrate is introduce a new way of running applications and just use HTTP between them. And even though, and I don't mean try and persuade your IT department that they want to run something other than an application server, because they won't want to, because they've spent millions on WebLogic or something, or they're standardized on something more sensible like JBoss AS. But make your Play application and deploy it in the cloud. So use Heroku.
Okay, but I heard that war deployment don't work on Play 2.0.
Well, it's not built in, but there's a war module. But I haven't used it, so I'm not sure what the limitations are.
Okay, thank you.
We've got questions here and there. And there. I can't actually see very well because the lights are high.
Is there any support for security in Play framework?
That could mean all sorts of things, but I think the answer is basically yes. If you want, so authentication and authorization, this is something that's fairly easy to do because it means wrapping these controller methods in something that adds authentication. It's a fairly simple technique which is described in the documentation.
Hey, so I got a question about the whole routing configuration file. Somewhere in your talk you said that you like having choices, right? But at the beginning you said that there are no annotations for it. There's just the routes file.
Correct.
So first of all, don't you think it would be better to give the developer a choice, like do this or do that? And the second part, won't the roots file be really cluttered after some time? Okay, it's good when you have like 5 mappings, but what if I have a very complex web application?
Okay, so to take the first question, which is, what if you don't want to do your routing that way? I mentioned that Play has a plugin architecture, and so you can write a plugin that intercepts the routing phase and just uses an alternate implementation. A colleague of mine did this for Play 1, and he did exactly this. He added an alternative configuration where you put annotations on your Java methods. Nobody uses it, as far as we know. But if you want that, then you can implement it. And if more people want it, then there's likely to be a Play module that gives you this option. But I think the reason is the answer to the second question, which is, doesn't your roots file become a mess? It only becomes a mess if your URL scheme is bad. If you design a nice API, you have a nice clean roots file, and actually there's not a problem. So in practice, it's not something I worry about. Even quite big roots files, and quite big means that it's 2 screens instead of 1 screen on your monitor, are very easy to maintain.
I got a question about security also.
Yeah.
Is it possible to integrate stuff like Spring Security to get the security on all application layers? And is it very hard to integrate with Play 2?
I'm going to give a sort of general answer to this question because is it hard to integrate something like Spring Security? Because of the way that Play works, it's very straightforward to just use anything that has a Java API because Play has the kinds of extension points and pluggability that if you want to integrate it with something that has a Java API, that's just going to be straightforward to do. So the answer is yes, just because of the same way that the answer is yes for can I use this persistence framework instead of that one. You don't have to do anything very special. It's just Java code. So yeah, that kind of thing works quite well. More questions? Yes, I see more questions. They can't see you.
My question is about the template engine in the first version when we are using all the loops and the control instructions. In the output HTML, we got many white spaces, new lines, and charts like that. How does it look in the second version? Is there any way to optimize it?
I saw a discussion about this on the mailing list last week. There isn't a fix for this yet because template syntax often introduces an extra white space, an extra line break. I haven't seen a solution. So the short answer is no, there's no solution. However, I'd like to add that firstly, it probably doesn't matter. It doesn't matter because it's valid HTML still. In HTML, you can put white space anywhere. And secondly, it doesn't matter because if you're worried about performance or the size of the HTML document, you can use gzip compression in general to not send lots of stuff over the wire. And of course, HTML compresses very well. So no, this is not a solved problem, but I also don't think it's a big problem. We have questions down at the front. I think there are a couple.
Okay, so question about this templating system. My impression is that, in fact, those templates are more or less just Scala code, right?
Yes.
So don't we somehow end up in what we had with JSPs, where when people just put code into templates and everything is, you know, it doesn't look as it should?
If I reinterpret your question slightly, is there a danger that people will put big blocks of Scala code in their templates? Yes, there is that danger. I would like to think that we've learned our lesson and that we've read dailywtf.com and that we don't do that. This is a common trade-off in template engines. You have to decide, do we allow all flexibility and power with which comes the need for great responsibility? Or do we have a template system like Mustache, which doesn't have any logic at all, and it protects people from themselves? Play uses the first kind of approach. You know, just don't do that. It's not the best answer, but it's not a bad answer. Okay, I think people want to come in for the next talk, so I'm guessing that's the end of the questions. I'll be just outside the door if you want to ask more questions. So.